Hello and welcome back to the lecture on applied econometrics. In this lecture, we are going to cover a very important topic. Actually, this is the beginning of it, which is called regression. And this is essentially going to be the main topic that we are going to cover in our module 2. And when we started this course, we told you that there would be 3 modules. And the module 2, which is essentially regression and its diagnostics, we are essentially going to do a correlational study. And one particular deliverable of this course is to have a clear understanding between the difference of correlational thinking and causal thinking. So, in this module essentially the regression models which you are going to learn, they are going to explain the correlational thinking in detail, right. So, before we begin, let me actually recap the concepts of causal thinking vis-a-vis correlational thinking. Now, when I said causal thinking, we said that causal thinking is really a holy grail in any science, any scientific pursuit, because we want to understand what causes what. We want to know the why behind certain phenomena. We want to get the exact explanation in the midst of all the plausible explanations. So, what I want to do when I do a causal thinking is that I want to know the exact x that is causing y, or if there is a certain path that x is causing z and z is causing something like maybe v and v is causing y. So, essentially I want to understand the phenomena, the mechanism that is actually leading one to the other, and why it is so important to understand the phenomena. I mean, if you look at any scientific discovery of a great magnitude or even a smaller magnitude, you need to know why it is happening. For example, if you see the discovery of, take anything like the fire, or discovery of the atom bomb, or discovery of electricity, any discovery happened because I know exactly precisely why certain things are happening from where, right. So, I know the mechanism. So, that is why causality is really important. So, it is like like when you have multiple plausible explanations. So, there are multiple plausible explanations to every phenomena, but when you do a causal thinking means exact understanding of why is very important, why certain things happen, right. You need to know exactly why certain things happen. So, you need to have this, and this is essentially the crux of the causal thinking. Now, if you actually take examples in, like when this the importance of causal thinking is understood in social science as well, in economics, social science, sociology, everywhere, and the same question was asked in different contexts, right. Particularly, for example, in social science or economics, we say that, well, so how the education of a mother really matters to a society. I want to understand the impact, and what I do, I actually have this data and I actually try to understand the impact of mother education, if that leads to prosperity of the society. Now, when I do that, so there are different ways of doing that, and particularly when you try to solve the problem using regression, we actually will see that essentially we are thinking from a like a correlational thinking. We are not really able to explain the causal path. We try to do that, and there are ways of doing that, and we'll actually see that. But essentially, when you talk about regression, we'll actually talk about the correlational path. Now, again, to recall the examples we have given when we distinguished between causal and correlational thinking, was the example of scurvy disease, right. Now, the example I will briefly recap, and the example was that the scurvy disease, it was found that scurvy disease could be cured with the, so let's say, with the use of with the consumption of citric fruit like lemon or orange, right. Citric fruit would lead to the cure of scurvy, right. And that was something correlational. People saw that those sailors who consume citric fruit, they actually are, they actually they are not likely to have scurvy disease. And Captain James Lind actually published a result of this study, and that became pretty famous, and people actually started to, take a lot of citric fruit when they are going for a sea voyage, and they actually the fatal disease scurvy was almost like vanished. Now, people did not know why exactly the citric fruit is actually helping you to get rid of the scurvy. So the explanation people had is that perhaps citric acid has certain acid, and this acid, so essentially what they thought is that citric fruit has certain acid, and this acid is actually helping us to cure the scurvy. So that is the sort of assumed causal path. Let's say this is an assumed causal path, right? I'm not sure about this mechanism, but I'm assuming that this is the causal path. Now, since people did not know the exact causal path, what happened is that many different, people actually started experimenting, because I don't know the exact route. So I have multiple plausible explanations. So, what I did was that some sailors actually started, say, boiling the citric fruit, because when you are going to, say, Arctic, regions, it is really cold, and you might just want to have, like a hot beverage that is made out of the citric fruits. So, and the assumption is that since the main ingredient we are concerned is the acid in the citric fruit, so it is not really spoiled when you boil it. And then people started consuming that, and surprisingly for everyone, the scurvy disease actually came back. Like after like maybe almost a century, the scurvy disease actually came back, and just to the surprise of the scientific community, like why exactly it has happened. So because the problem was that they did not really understand the actual causal path. It was assumed. It was only a correlational thinking that led them, this vagueness. They did not know exact causal path. So some people actually tried to boil it. Some people tried to actually have Spanish lemon or Indian lime, which are actually less in, say, I think 25% of actually vitamin C, let's say, which is the actual ingredient, which is later on discovered. So what happened is, because of the substitutes actually were not really functional, and because they did not have the causal understanding, they actually ended up taking all these different ingredients, and because of that, the scurvy disease actually returned back. Now, only when the discovery of vitamin happened in the year, I think 1913, people actually started to understand that, okay, there is another ingredient called vitamin which might be there in the citric fruits. And I think later, around after 2-3 decades, people discovered that it is a vitamin C, which is the main reason that actually helps us to get rid of scurvy. So actual causal path was, so the assumed causal path was this, citric fruit acid to scurvy, and actual causal path is, so assumed, let's say, let me use a different color, assumed causal path was, and say actual causal path let's write down, it is the citric fruit acid to scurvy recovery, let's say, and the actual causal path citric fruit vitamin C to scurvy recovery. The reason we have given this example previously and again now is that it is really critical to understand this causal path, right? But we cannot really do that with correlational thinking. When we start learning regression, initially we'll see it is only correlational, and as we proceed, we will see how we move from correlation to causal thinking by bringing more and more complexity in our regression equation. Now, when I talk about correlational thinking, we know that the first thing that we learn is a scatter plot, and in a scatter plot, what we do, we have, say, two variables. So let's say now I take some variables like let's say earnings and say education, let's say, and what we see is in general there is a positive sort of relationship between, sorry, let's say different color, positive relationship between earnings and education, right? And I know the method, like what I do from the scatter plot, we actually draw a regression line. We actually end up drawing a regression line, right? We end up drawing a regression line. Now, when I draw this regression line, so when I actually have the scatter plot, I know something called correlation coefficient, and for a regression line, we know something we care about is, so in general, we calculate correlation coefficient. We will see what we mean by correlation coefficient, and we will calculate something called coefficient of determinants, but that we will do when we actually calculate it further. So, but the idea here is that when we draw this regression line, we essentially, we essentially want to minimize the errors, right? We essentially want to minimize these error terms. And when we want to minimize these error terms, how we do that? We essentially call something called residual sum of squares. So we could draw this line. We could draw this line just randomly. We could just just visually see these plots, and we can simply draw a line which is probably somewhat equidistant from all the different points. But then it is not really, it is a subjective way of doing. We really don't want to do things subjectively. We want to determine the line objectively, and that is why we try to draw a line for which we have basically the errors from all the points, the distance between all the points from the line is actually minimum. And to do that, what we do is we essentially calculate this residual sum of squares. Now, one way we could actually calculate these errors, and we can actually see this minimize the error is actually we can sum total all these errors, right? So, one that is U1, U2, UN, let's say all these different points. So, this is let's say U1, this is U2, and this is UN, let's say all these different points. Now, but we don't do it because the problem is if we do that, so what will happen is the errors on different sides of the regression line will actually cancel each other. So, we don't want that. We actually want to capture the overall error, and to do that we actually need to square. We actually need to square these error terms, and then we need to take the sum, and that is what we call a residual sum of squares or RSS. Let me write down here, or RSS. Now, how do we compute RSS? RSS is equal to nothing but summation of UI square, U2 square dot UN square. Now how do I sort of minimize the RSS? It is quite simple. So, if I have this regression line, I will write an equation for this line, and that equation is going to be y, let's say y. So, this is I am writing about equation about this line. So, y hat, it is going to be y hat, this is the estimated y is equal to, let's say B1 plus B2 xi. Xi is all the different x points, right? All the different points corresponding to education, and y is my earnings. Okay. Now, when I want to, so this is my actual yi, this is my actual yi, and this is my estimated yi hat, right? This yi hat is coming from this line. Now, when I actually do that, so essentially, when I actually calculate this residual sum of squares, and when I want to actually minimize this error, so all I need to do is to minimize residual sum squares, So, RSS I have to differentiate with respect to the two coefficients, because these are the, or parameters in our language. So, these are the two parameters which are defining this line. So, d beta 1 b1 and d RSS d beta 2. I am not really going to derive it, because this is available in any standard textbook. So, you would rather see that, but the result that is going to be helpful for us is that we need to estimate the beta parameter, and this beta parameter that we are going to see basically or B basically here is that B2, the value of B2, the coefficient or the parameter corresponding to the x variable is covariance of xy by sigma x bar square, and if I expand it, it is basically xi minus x bar yi minus y bar by summation of xi minus x bar square. And this way what I am going to get finally is that regression line which I have been looking for. So, for all these different points, I am going to have a line which has a, so let us say this estimated my B1 and this slope parameter B2. Okay. So, this is how I get my simple linear regression line. Here I have taken only one variable, that is education. Here my x is education, y is my earnings. Okay. So, I just have one variable, and that is essentially we conceptualize the idea of regression. Now, this is the first part of the lecture on regression, and in the next lecture we are going to see how we estimate or how we actually conceptualize multiple regression.